Why it keeps deciding to crash. Are we live? Let's find out in a second. Yeah, I don't know what it is. It doesn't even notify me until I think like 2 minutes after it's crashed, which is a little bit irritating. So what do we want to do? Let's do the sweep out for each, make sure we're fine. So how far is this going to move? A is going to move H as it goes down. So A is going down. Are they released from rest? They're both released from rest. So they both have U as 0. We're going to have V we don't care about. And A will be G. And the T for this one is going to be just some time. So we don't know exactly how long. But what I'm going to do is call it like just capital T. Similar for B then. B is going down. What things do we know? It was released from a lower height. So K times H. Again, U is 0. A is going to be G again. And T will be whatever time we've put over here minus T. We can think the other way around. This is going to be like the time it takes for this to fall. No, tell a lie. Tell a lie. Yeah, if this takes so long, T seconds. Yeah, it is. This is T minus T. Big T minus little t. So big T is how long it takes the A to do it, and little t is how long it takes the B to do it. So we want to solve these, and we will get simultaneous equations for H and for T, I think. And we want to rearrange then for this T. Like T and K need to go in there. So what we're going to have from the right-hand side, we don't have V. So it's S equals UT plus a half AT squared. So GT squared on 2. Left-hand side, S is KH equals U times T. It's gone again. Times a half of A, so times by G on 2, lots of this thing squared. So this looks good. We want to end up in this situation to find T. So yeah, we need this one. So what goes away is capital T and the H. So can we plug in there? Yeah, let's plug in that for H. I'm going to do some stuff over here. Yeah, plug in for H. So we'll have K times this. So K, G, T squared on 2 equals G on 2, T minus T, all squared. G's on 2 can cancel. So we have kt squared is equal to, expand that bracket out, big T squared minus 2tt plus little t squared. Bring this all to one side then. We're going to have t at 1 minus k lots of t squared minus 2tt plus t squared equals 0. This then is some quadratic, and I'm hoping that we get one solution that is this thing. Doesn't seem like we're going to. I feel like something might have gone wrong here somehow. Oh, 5 seconds after. Okay, I've overcomplicated this. Let me go back. So let's say 2 seconds after A was released. Okay, yeah. So T is 5. T is 5 this side. So S equals UT plus a half A T squared. So 12G on 5. Yeah, 12G on 5. So let's go on this side then and plug that in. So this is going to be 12 kg. 12 kg on 5. And this thing then, we know that the big T was 5, so it's 5 minus T. So that should be 5. And this thing should be what we have up there. Again, G on 2 can cancel. No, tell a lie, G can cancel. But we will times by the 2 and times by the 5. So 24k is equal to 5, lots of 5 minus T, all squared. We want T, don't we? So yeah, it's not a quadratic now. We can, well, it is, but we can just rearrange for T. Yeah, so actually we'll divide by the 5 again. 24 k on 5 square rooted is 5 minus T. Add the T and then take this away from 5. We should have 5 minus that thing is T. Doesn't seem so nice, but let's try and like expand some brackets, see if bits pop out. I wonder if some numbers are just wrong somewhere. So 5 minus root of 24, okay, lots of times by root k over root 5. What is 24 on 5? All rooted. 2 root 30 on 5. Nah, something's wrong with my numbers somewhere. I think we've got the right method. You can see the numbers are popping up very close to what we want. So we've got 5 lots of 1 minus, well, 5 minus 2 root 30 on 5. What does it say in the mark scheme? Number 16. Height is that. So yeah, we get the right height out. That's good. Like that being correct. That's good. Uses this. Yeah, we did that. Reduces time. Should it be B plus? No, it should be that one, shouldn't it? I think unless it should be D, like plus. Unless it should be plus. But I think everything we've done is not too bad. So 25 on 2. How did I get 12 on 5? No, it's just that number's wrong. How have I got that number out? Where did that come from? So S equals UT plus a half of A. Yeah, that's why, because I've just written this number down wrong. So this should be 25 on 2, not 12 on 5. I think if we just change that number, hopefully everything's right. So 25 on 2. 25 on 2. 25 on 2. So yeah, the 2's do cancel out. This should be 25. Not doing blue. It should be 25. From here, I will just restart. So we want to square root that. So it's going to be 5 times by root k. That would be 5 minus t. Add the t over, take this away from the 5. Yeah, this is looking good. 5 lots of 1 minus root k. That looks good to me. Yeah, fully justify. What does it mean by that? Doesn't say anything in here about that. Okay. So 18 then, let's look at that one next. What do we have for this? 18, so some moment stuff. Not moment, sorry, even some frictional things. Mu was 117, did we get that right? Mu, oh yeah, that's good. That is spot on, 8 marks, lovely. B part 2, is it just like a little something? No. The string breaks. Okay, yeah. So the string breaks after moving. How long is it going to keep going? So what you want to think about is like what's actually happening. We're being pulled up, are we? Yeah, we're being pulled up. So we're being pulled up. We will have some acceleration that we found probably as we're doing the thing, or that we were given. B is released from rest. It begins to move downwards vertically. So we have 5, 4, 3 on 6, 2, 5. A is 5, 4, 3. 6, 2, 5. That's in the first little section. After the string, where am I going? After the string breaks, this is still going to be going up, but it's going to be stopping now. So what you need to do is go in and get all the values that are going to be bringing it down. So if we have the item, we've got the weight coming down this way. How much did it weigh? 0.2, so it's G on 5. And we're going to have some friction this way, which is going to be mu, which we know is 0.17. So 0.2 times 0.17. 17. What are we doing? We need to find out what R is, don't we? So R is going to go this way. This would be 0.17 of R. I'm pretty sure the R is the same. Like it's still just going to be cos of the angle. Yeah, we've got this thing. So R should be G on 5 cos of that angle, cos theta. So we have that the frictional force is going to be 0.17 or mu. We'll just call it mu for a second. It's going to be mu G on 5 cos theta. That's for friction. And we want to get the acceleration from that because that's going to be the only thing alongside the weight that's going to be putting us down the slope. So what's actually putting us down is that friction. And also, the component of the weight the other way around. So it's going to be G over 5 sine theta. So altogether, we've got G over 5 in both, yeah? So G over 5 mu cos theta plus sine theta. So that is our net force in that direction. So dividing that by the mass gives us acceleration in that direction, which will just be that divided by the fifth. So without the fifth in there. So that's the first acceleration. The next one is G lots of sine theta plus mu cos theta. This is some number that we can get, yeah. But this is some number. You can work with it as some number. What is that going to be? Do we have sine theta and cos theta somewhere? No, but we do have the value of 16.26 for theta. Theta is 16.26. So let's work this out. My in degrees, I am 9.8 sine of 16.26 plus mu, which is 0.17, times cos of 16.26. That gives us 2.9. Yeah, we'll call it 2.9. What that is going down the hill, yeah? So we're going to have some period where we're being pulled up. We're being pulled up by the rope, and then the rope breaks. But we have that little bit where we're still moving up and then we stop. So this is going to be like the first section before the rope breaks. We use that to work out the distance we travel. And then this one we also have like now, well, and the speed that we travel to. Now we have the initial speed, and we can use it to work out until we stop, basically. This is 0.87. So, did we have anything about time or anything like that? What did it tell us? When it reaches the speed of this, find the distance travelled after the string breaks until it first comes to rest. Okay, so they've done the first part for us, basically. But what we have now is some suvat where it's going to be speed was 0.5 to start. We want to go to rest, so it's 0. We're decelerating, so it's 2.9, but negative. And what did we want? Distance. So there's no t. V squared is u squared plus 2as. So the v is 0. U squared is going to be a half squared, so a quarter, plus 2 times the a of 2.9, so that's minus 5.8, lots of s. Yeah, let's make that 2.5 as well. So 0.25 minus 5.8 s. S should be equal then to 0.25 over 5.8. What's that going to be? 0.25 over 5.8. That is a number of 0.04. And like again, does that make sense? It's like, what, 4 centimeters, isn't it? It's 200 grams being pulled up. It's on a thing that's not actually that rough, but it's not good. It's not going to be moving too fast. Do you mean? 1.5 meters per second. So just a half a meter per second. That's not that fast, and then just stop like pretty quickly. But that does seem quite quick. So let's double check the mark scheme. I have got it. Oh, actually, my hands are too big. My hands are too big, not too small. What's gone wrong? This number is not correct. No, not correct. So somewhere in here I've got something wrong. Let's do this bit differently. I'll pull that out. What's that actually on this obstacle? We have weight going down, 0.2 g. We have this going this way, which is going to be 0.2 g cos theta. What about? We don't have that. We have the reaction force going this way, which should be 0.2 g cos theta. So it's mg cos theta. This is going to be the friction going this way, which is going to be mu r. So it's mu mg cos theta. So what's pulling us down that way? Let's make that mg again on the floor. Is mg lots of mu cos plus sine theta, which is what we had, and then we just plugged in the value for theta. Maybe the value for theta is wrong. What have they got? Well, they have sine theta and cos theta in the mark scheme as sine is 0.28, cos is going to be 0.96. So doing inverse cos of that, what do we get? 16.26, yeah. So I don't know what we did wrong then. How do we get a different value for acceleration? So acceleration is just going to be that. That's ma. There's no other random force, is there? No, no other random force, I don't think. What have we missed off then? So ma would be equal to that. So divided by the m's. That is that. That is that. Let's just plug it in. See if I might just type it in the calculator wrong. 9.8. Lots of 0.17 times 0.96 plus 0.78, 0.28. And I get 4.3. Yeah, I think I might just type that in the calculator wrong. Everything we've done is right. This number is just incorrect. So if we change that through, oh, that's why, because I've just written down, oh no, that's fine, no. Yeah, it's still wrong. Like, I don't know, this number's wrong. This should have been the 4.34. Everything apart from that, I think was fine. I just wrote down the wrong, like did my calculator wrong, basically. So, oh, and that should have been, no, that's fine. That's 2AS, so that gets double done it. So that's going to be 868. So on the bottom should be 868. And then when we do that, what do we get? 0.25 on 8.68 is going to be 0.0288-ish. That look good? Yep, spot on. Hopefully that all makes sense. So yeah, we needed to think about, as the string breaks, it's still moving. So if you had the whole journey, you'd want to work out the acceleration. Like, say you didn't know the half a meter when it broke, you just know for, like, say 5 seconds. You would want to work out, using suvat and the original acceleration, how far, fast, and like time does it take when it breaks? And then afterwards, so you've broken the tension, what's the new net force? Use that to work out the new net acceleration, and then do a suvat with that, where like the final velocity before it broke is the initial velocity after it's broken. So hopefully that all makes sense. Right, yeah, aqueous mechanics today, and we're going to go back to pure now, because everyone's got pure. There's only a few bits of mechanics, but hopefully, Sharon, this was one of my students' papers. I just marking this to see any little bits he's not got correct. This is good though. 8 marks for that. Yeah, really good. Just yeah, when the string breaks, you have to kind of work out the speed just before it breaks, and then think about the acceleration after it's broken. Do different suvats for each one. So back to core then. Back to some core questions. Let's see what other bits we've got. Let's go back up here. What can we do? If you guys have anything particular, let me know. If not, we'll do this weird little modeling tray thing. So the horizontal base is a rectangle measuring 8x by y. 2 vertical sides are trapezia of height x with parallel edges of 8x and 10x, blah, blah. 2 main sides are, 45 degrees. Capacity is this. Do we get the volume of this thing? How do we work out what is the volume of the area of this shape, or the volume of this shape? What are they called? Well, it's a base, isn't it? Okay, no, we can split it into bits. This thing is all flat up. Like, this side isn't leaning towards us, you know what I mean? It's going straight up from the ground. I'm pretty sure, because like this side should still be y. So if you want to think about the volume, we can basically split it across there, yeah? And then draw down on that side again. So that side to there, and then down. So what are we going to have is some big cuboid, where the volume then is, how long is that cuboid? X. How fat is it? It's y. How tall is it? Another x. So that's for like the first bit. And then we've got these shapes on the end, these like prisms on the end. What's the area of this little triangle? Well, the height of it there is x. The width of it there is x. So the area there is a half x squared, then times that by a y. So x squared times by y on 2. But we have 2 of them, one at every end, yeah. So it's just plus that thing. So this is 9x squared y. That looks good to me. The capacity is 900. So what we have is that is equal to 900. So divide by a 9. X squared y is 100. So what do we want to do with that one? Find an expression for y in terms of x. So y is going to be 100 over x squared. Find the area used to make the metal tray. Well, it's got no top, is it now? Nothing on the top, it's just open. So what shapes have we got? I've got my big rectangle on the bottom, 8x times y. I'm going to have this shape. That's a trapezium. But I'm actually do the rectangle. So I've got 2 of these rectangles and then just add on the triangles, yeah. So 8 long, x high, that's going to be 8x squared. And then we'll have the triangles on each end, which were x squared on 2. So there's another x squared there. but I've got that front and back, so I need to double all of that stuff. And then I have like the falling over sides, like these little ones. How big are they? They are, ooh, they're a little bit sneaky. They're wide this way, but then we need like this length, don't we? So that is going to be root 2x. So I think if you do x squared plus x squared, 2x squared, square that, root 2x. So root 2xy, but we've got 2 of those. So 2 root 2 xy. Collecting all these bits up, what do we get? I've got 8 plus 2 root 2. Lots of xy. And then expanding these brackets out. Well, not expanding them out, but what have I got? I've got 9x squared times by 2, so 18x squared. 18x squared popping out is nice. And what we can do now is use the fact that we know that y is 100 on x squared. So let's plug that in there. What do we get? So it's going to be 100 times by, well, 100 on x squared. So if we times this by x, it's 100 on x, yeah. So it's going to be 100 on x, lots of these things. 8 plus 2 root 2. And then plus the 18x squared still. And let's just factorize a 2 out of that bracket. So 200, 4 plus root 2 over x plus 18x squared. Looks good to me. We want to find the stationary point of this. So let's do dA dx. This is just like something x to the minus 1. So we'll times by the negative. We'll have 200, 4 plus root 2. Drop that power down from minus 1 to minus 2. And then we'll have 36, lots of x. Set that equal to 0. So it's equivalent to having, like, get rid of that bit. They're equal to each other. Times that across to make it a cube. Divide by the 36 and cube root. So it's 200, 4 plus root 2 over 36. All to the power of 1/3. That'd be x. Show it's a minimum. So d2x, d2a, dx squared. This is going to be 36. Here, if we do negative 2 times everything, we'll have 400. And then with the bracket. And then the power is dropped from minus 2 to minus 3. Looks good to me. We know if what we had was positive. And this is going to be positive whenever we put positive things into it. So therefore what we have is a minimum. Looks good to me. Like I say, any other questions, whack them in the chat, and we can do any questions you've got in particular. Not long now, innit? Not long, half an hour or so. I don't know what time you guys have got to leave. I assume it's pretty soonish. I'll keep going until like midday, maybe. I think that sounds good. But any other types of topics you want me to look at quickly, just give me a shout in the whatchamacallit, in the chat. Just whack any questions in the chat, we can do them all. If not, I'll start to do some random bits. So second and third terms are this. Find the common ratio. So R is going to be the division of those two. Log base 3 of 16 over log base 3 of 4. On the top, that is 4 squared, yeah? So we can take a 2 out the front. Then you'll have log 3 of 4 everywhere. That's just going to be 2. So the first term is equal to this. So if there's second and third, what we have then is that A is going to be the second term divided by 2. Well, that is, yeah, a half of log 3 to the 4, which is going to be log base 3 of 4 to the half, which is log base 3 of 2. Looks good to me. Find the sum of the first 6 terms. So what do we have? We know that A is log base 3 of 2. And we know that R is going to be 2. So sum of the first 6 terms. So sum of 6 will be A. Lots of 1 minus R to the n over 1 minus R. So as we do that, what are we going to get? Log base 3 of, not of, hold on, what should that have been? It's log base 3 of 2, sorry. That is just our A, yeah, nothing funky's happened with that. Log base 3 of 2 times by 2 to the power 6 is 64, take away 1 is 63. So 63 out the front. Lovely jubbly. Oh, why are there so many? Yeah, because the stream keeps crashing. I don't know why. I don't know what it is. I keep lowering the quality. Does not like it. I've streamed before. It's not crashed ever. And now today it seems to just be crashing non-stop. I think it's my iPad. It froze the other day for like an hour, which is not good. And then I've updated it, and then since then it's been like struggling, struggling. It's on its last legs. I might get a new one when I go to uni in September. Any tips to get an 8? Just be calm. Do you mean like there's nothing you can do now about learning stuff? The best thing is just confidence. You've put in loads of work over the last like 6 months. Just like, yeah, double check everything. Don't worry too much today about like, do the answers seem horrendous? With what happened in paper 1, the answers were mostly horrendous, yeah. So if you get an answer that is horrendous, it's probably like where normally I'd say that you double check that because it's horrendous. I don't do that today. I would just go through and do them all, and then at the end double check the ones that you think you can do. Yeah, don't try and rush. Just get bits done that you can get done. Try and do the bits that you know what to do first, instead of just thinking some random bits. But yeah, that should be it. I don't think there's much other stuff that you can think about. Make sure you have the double check your calculator. Maybe the way to do things. Just like any bits you do on the calculator, just think, okay, does that actually make sense? And at the end, do like quick calculations you can do. Or I suggest like do everything with algebra. Don't plug any numbers in first. Do everything with algebra, and then you just put them in at the end. So if you did make something mistake like on the calculator, it's only done on the last step. You've not got the mistake on like the first step where you've done 2 times 4 and you've put 7, and then like that's just wrong all the way through. But if you've just left it as like 6 or C, sorry, as you work through it, the very last step you plug in the value for C, you're still all correct all the way through, even if then you put in the wrong value for C at the end. Same thing happens if you can't find an answer. Say you can't find an answer for part A, but it's like you need to do that for part B. So like where it would normally be a show that, but you can't show something, just make something up for part A. If you can't do anything, make something up and then use that. Or if it's meant to be a number, either make a number up and use that, or just call it A and then work with A and see what you get for it. Yeah, apart from that, just good luck. Be calm. It should be not too bad. Any other types of questions you can think of? I'm seeing which ones are interested in here. There's any bits that generally people are stuck on. Done that sort of stuff. Maybe we'll do one more of these things. Is there one on all one page? Yeah, we'll do this thing. So what have we got? We've got some cylinder, right circular cylindrical metal rod. It's expanded at as it's heated. Blah 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 blah. So just in general, what do we have? We've got radius, we've got time, and are we talking about the surface area or the volume? Volume. But we also have cross-sectional area. So we've got all four, sorry. And then we're going to have to eliminate one and work with the other ones. What things do they tell us? Well, we've got these volumes. So we can actually just work out what the volume is. Volume is going to be equal to pi x squared times this. So it's 5 pi x cubed is the volume. So radius, I'm going to replace up there with an x. This is good. Whether we need this or not, let's do dv dx. We'll get 15 pi x squared. Some part of me is doubting that this is just pi r squared. Yeah, pi x squared times 5x. Let's get that. Yeah, that's good. Now then, what have they told us? This is the cross-sectional area, is this. And you can just look at the units again, A and T. Area and time was 0.032. We're going to find dx dt. What things do I know? Well, we've got to keep a dx there. We've got to keep a dt over here. And either then, it's going to be A or it's going to be V. So which ones do we have? We have a V, but we also can do the same process, like this sort of stuff, but with the A. So let's move that over there quick. A is going to be pi x squared, and dA dx is going to be 2 pi x. So where we have the choice about like which one do we use, A or V, we only have a number for A. So that's the only one that we could have, like dA dt we would have. We don't have a dV dt. So we're going to have to use dA dt. The dA dx we just found, but we want the opposite, the reciprocal of that thing. So 1 over 2 pi times by x, and then dA dt was this 0.032. This looks good. So if we half that and put it on the top, we'll have 0.016 on pi x, and then we want to sub in the value for when x is 2. So halving that again, 0.008 on pi, whatever number that ends up being. Rate of increase of the volume, so dv dt, dv and then dt like that. And what things do we know again? Well, we actually know quite a lot of stuff now, do you mean? This is when that is 2, this is when that is 2. So we could just use that one if we want to. So this would be like dx, and then do we have a dv dx? We do, lovely. The other one would be area, and it'd be quite hard to see exactly what would be going on. Like we need a dv dA, and that's quite hard to like pop out. You can do it, but yeah, it's not so easy. So dv dx, where was that? That's the 15 pi x squared from the top middle. dx dt, we just worked out 0.008 over pi. Goodbye pi's. If we do 0.08 times by 15, what do we get? We get 3 on 25 actually. So it's 3x squared on 25, and we want to plug in 2. So dv dt when x is 2 will be 18 on 25. That's good to me. Again, might be some number errors, but it should be that the algebra is fine doing the process we're doing to get there. Should all be good. Let's think. We'll do 1 or 2 more, then we'll call it a day because you guys should get yourself going, get to college, get there earlier on. Let's see what happens if I go on to that other one with the hardest one down here. Oh, this one that bloody loads in it. Come on. Right, what we got? Yeah, we'll look at this quickly.